Start.
Excellent. Thank you very much, Chris. Welcome all. So we're going to have a very quick session. As Chris said, it's 30 minutes is our allotted time. I'll try to stay within that, but I'll tell you right now, we're probably not going to. We have a lot of information to cover when it comes to adhesives and some of the practical guidelines, etc., as to how to use the adhesives. And at the end, we're going to go through a little bit out of the floor covering reference manual as well. So let's get started. See if I can get this to go here. There we go. So adhesives that are used in floor covering, there are a number of different chemical makeups for them. There's a reason for that. Just as in golf, we don't just carry around one club. We use different clubs in order to get us to different parts on the course. And it's the very same thing with adhesives, because there are so many different types of floor coverings, floor covering backings, etc. Manufacturers have had to build different types of adhesives. So some of the ones that we're going to go through today, SBR Latex, Acrylic adhesives, epoxy adhesives, urethane, and Silane modified adhesives. So if you've been in the industry for a while, you've probably seen the progression of these. SBR used to be very, very popular. They've given way to acrylics. Epoxies and urethanes used to be very, very popular. They are giving way now to the Silane modified types of adhesives. So we're going to touch on each of them, but keep in mind that some of them are older technology and you're probably not going to see them as much as you might wonder. So SBR latex adhesives, very simple. They're styrene butadiene rubber. You take a hydrocarbon resin, you mix that with a process oil, you add some filler, and you add some water. The butadiene rubber obviously gives it a little rubberiness to it. The hydrocarbon resins, rubber isn't terribly sticky, so the resins are what makes it sticky. The process oils that are added, those used to be solvents. So back in the day, that would have been some type of solvent. However, those have been taken out years and years ago. And now we use an oil, and then the filler and the water. Now, we'll just say right at the start here, we're going in cost from top to bottom. So as we go through the different adhesives, you will notice that as we mix them up, the different recipe up, you're going to see that the cost is either going to go up and down. And also too, will the performance of the adhesives. So SBR latex adhesives, these are not used a lot in the industry anymore. We're really seeing them mostly. We're going to see them in VCT adhesives and carpet adhesives that have standard carpet backings. However, because standard carpet backings are slowly leaving the industry in favor of vinyls, we're not seeing them even in the carpet industry as much as we used to. So how do we build them? Well, if you need VCT, what do we want out of a VCT adhesive? We want it to be very sticky. We want it to set quickly. And we would prefer it not to be expensive. However, that's hard to do if you want the other two qualities. So you can see from the little graph there, we have high SBR, so it's a little bit soft and rubbery. That allows it to be a little bit stickier when we add the resins to it. We don't want it to be cloudy. We want it to be clear because you want to be able to snap your chalk lines underneath of it. So we don't add very much filler to it in order to keep it clear. And because we want it to dry fast, we only add a little bit of water to it. Obviously, as we discussed on the earlier slide, this is going to be a little bit more of an expensive adhesive because of the way that it's built. However, you get the qualities that you need in order to install VCT. This, by the way, is becoming the go-to now for VCT adhesives, is the clear thin spread. If you've been in the industry a long time, you will remember the asphaltic adhesives, what we call blackout. Those have slowly given way to the clear thin spreads. And in fact, we see this really taking over the industry. We don't see a lot of blackout going out anymore. It's very, very difficult to work with, hard to clean up as you go along. You really need a solvent in order to clean with it. And so the clear thin spreads are definitely taking over the industry as far as VCT adhesives go. For carpet adhesives, there's different ways of building a carpet adhesive. So a wet set, carpet adhesives are always wet set. And what do you want out of them? So if you want a high performance one, if you're doing hotel work, where there's a lot of cleaning, very, very high traffic going on, you're going to want a high performance type wet set. So what do? Well, we want it rubbery again. We want it to stick really good. So we add some SBR and resins, a little bit more filler because we don't necessarily need it to be clear, a little bit less water. Once again, we want it to set quickly. And so this is how we build our high performance wet set. Again, cost is going to be a little bit higher because we're adding lots of SBR and lots of resins compared to the rest of the solution. However, the performance is also high. So very high bond and very high shear strength will stand up to the type of traffic that we're seeing. I mentioned hotel work because, to be honest, this is a lot of places where we're seeing high performance carpets going in is going to be in hotel work and those types of industries. The regular day-to-day office buildings, etc., have all switched out to the carpet tile industry. If we want to build a mid-range multi-purpose, then we start dropping down our SBRs, we drop down our resins, we equal them out with a little bit of filler and a little bit of water, and we end up with a mid-range. Why are we going to build this type of adhesive? Well, because for felt back sheet goods, you don't necessarily want a high SBR and really great immediate grab because you need to be able to move them around. Now, a lot of felt back sheet goods, we don't see a lot of those anymore either. So again, as per our discussion, these adhesives are really, we're finding less and less of these adhesives being used as well. We can get a little bit even less performance out of a base grade. And you're going to ask, why am I going to use a base grade when all these other are available? It's because, you know what, sometimes you don't want performance. Your floor covering is only going to last 3 to 5 years. Why are you going to use an adhesive that's going to last 20? It's going to make it a lot harder in order to switch it out over time. And so you'll notice that a lot of times in those instances, say CRUs, some office places, rentals, etc., they may use either sheet goods carpet or felt back vinyl still, and so they may use a value priced latex adhesive in order to get to the price point, and they don't need the performance. SBR latex adhesives, so wide range of performance attributes. You can build them any way you want in order to get the attributes you want. You can make them very durable and high performance, or you can make them economical, designed for felt back and fibrous back floorings, which would be carpet types, not carpet tile, however, because of the high moisture content, etc. They don't bond as well to vinyls, and also too, they keep the moisture in. So we go to a latex for that. So we'll move on, or an acrylic for that. Sorry, we'll move on to that. Downsides of them, they're not always freeze-thaw stable. This applies to almost all of the adhesives. Very few of the adhesives are going to be freeze-thaw stable. We don't like it as manufacturers when we freeze our adhesives. The other downside, and the reason that they're not used a lot in vinyls, they are very sensitive to plasticizer migration. So SBR adhesives can cause a problem with when you use them with vinyls.
Hey, Brent, just expand a little bit on plasticizer migration for the audience.
So plasticizer migration is literally the plasticizers will come out of the material of the vinyls, and they will break down the adhesive. So it'll start to get gummy underneath the adhesives. It breaks it down. Plasticizer migration. You'll also get discoloration on the top. So if it's a pure vinyl, you can get discoloration on the top of will actually come right through the vinyl. So it is a chemical reaction between the two that will happen with an SBR latex adhesive.
Great, thanks.
Yep. So how do they work? They dry by evaporation. The resin solution breaks down. That's what gives it its legs, etc. What affects the performance? Moisture, plasticizer migration, temperature, and the pH of substrate. You're going to see this get repeated over and over as we go through all of our adhesives. So this is the old dinosaur of the industry. They're used for carpet and fibrous backed resilient flooring, or what we call paperback flooring. You can see that they're not used a lot in the industry because most of the industry now is going to be vinyl back carpet or solid vinyl flooring, and they're not used in the wood industry as well either. What is being used are acrylic latex adhesives. So you can see from the recipe there, less products go into the recipe. It's acrylic polymers, fillers, and diluents. And these are mixed in order to get the performance necessary. Very often, we're not mixing up the recipe per se. We're just changing the acrylic polymers that are used within the adhesives. So you're going to find that with acrylic latex adhesives, typically they all end up around the same price point. Some may be a little bit higher because of the polymers that are used. Some may be a little bit lower, but it's not going to be as wide a range as you're going to find with the SBR adhesives, because we're not moving around the chemical makeup, etc. of those.
So quick question, Brent.
Yep.
The fillers are bringing color to the product so you can see what you're doing when you trowel it out?
The fillers are doing that, and the fillers are also, particularly with SBR adhesives, they're giving it body. Right. That is a little bit less with the acrylic adhesives. You're right, it's more for color. Gives a little bit of body, but typically with the high solids, there's a lot of polymer in there rather than fillers.
I may have missed your explanation of this, but diluent, what is that word?
Diluent is just the product that's used in order to mix the solution. It's a really fancy word for water in this case.
So making it spreadable.
Yeah, that's exactly.
Okay, thank you.
Yeah. So I don't want you to get too hung up on the next few slides when we talk about the glass transition temperature. Very simply, this is when polymers change from crystalline or a glassy state to become softer and rubbery. Who this matters to, the glass transition factor, it says it really matters to the chemists as they build these materials, because the glass transition factor or temperature of the polymer will decide which type of polymer they're going to use in order to come up with the type of product that they want. So what that means in the industry is, if you're going to design a wet set acrylic at normal temperatures, once it sets, you want a wet set acrylic to stay rigid. So you want a hard set acrylic, a hard set adhesive underneath once it's set. In order to do that, you need a very high TG, or glass transition temperature. So in normal temperatures, say at 20 degrees Celsius and higher, there's going to stay very rigid. It's not going to get soft. That means that you're going to have a very hard set type acrylic. Why do we want a hard set acrylic? Because sometimes you need a permanent installation of solid vinyl sheet, rubber sheet flooring. You need a very hard adhesive underneath, particularly for rolling loads. It can stand up. It's not going. The material's not going to move around. The wheels aren't going to indent into the adhesive. So particularly in industrial use, or in commercial, heavy commercial, industrial, institutional use, you're going to be usually using a wet set acrylic underneath your vinyl flooring. Again, when a chemist realizes that, he wants one with a very high temperature glass transition temperature rating. The opposite end.
Let me just comment. That's interesting, because now the way my brain works, I'm seeing that we don't want the movement in the adhesive when you have a rubber stuck down to it or in it. You want the movement within the rubber flooring itself.
That is exactly.
Nice. Okay.
Yeah. So a hard set will give you that. The opposite end of the scale is a pressure sensitive adhesive. A pressure sensitive adhesive you want to be soft. And the reason for that is because you want retact characteristics on it. So with carpet tile, when you have a pressure sensitive, what we call pressure sensitive releasable adhesive, it has a very low glass transition temperature. So at normal temperatures, say 20 degrees Celsius, it's going to stay very soft, which means that it's going to stay very sticky. And so over time, it will keep those characteristics. And so you can lift the carpet tile, you can put the carpet tile back down. Perfect type of adhesive for vinyl back carpet tile and fiberglass reinforced sheet vinyl. Now, why the glass transition temperature matters is this reason. You will have noted that when luxury vinyl plank was first introduced into the industry, and even now, you will find that manufacturers will not recommend using a pressure sensitive adhesive, particularly in extreme environments. So we all went through the phase where do not use pressure sensitive adhesives with luxury vinyl plank when you are in front of windows. Why is that? Well, the luxury vinyl plank has a glass transition temperature, and so does the adhesive. So if you use a PSA with a very low glass transition temperature, remember at service temperature, so at 20 degrees, it stays soft, pressure sensitive characteristics. However, as the temperature rises, it gets softer. And so as the temperature rises, it starts to allow the material, or can allow the material, to start to slide around. That's why glass transition temperature is so important when you're a chemist, because as you're building these materials, you have to know where that temperature is going to end up. Now, those are the two extremes. There's also another type of adhesive, and that's what we call a transitional pressure sensitive. Now, this one is very interesting because a transitional pressure sensitive starts with a very low glass transition temperature. So at normal temperatures, it's going to be very sticky. It's going to be a pressure sensitive type adhesive. Going to be able to pull it up and off. However, over time, its glass transition temperature changes to be quite a bit higher. And so it starts off soft and sticky, but moves up in order to become very much like a wet set, hard set adhesive. It doesn't quite get to what we would call a hard set type attributes. However, over time, it does slowly build, I'll call it strength, but it actually builds rigidity so that it becomes closer to a traditional wet set type of adhesive. The reason that you want it to be pressure sensitive to start with is because of the way that installations are done. And as I'm talking, you're probably realizing that these are the types of adhesives that are being used for luxury vinyl plank, luxury vinyl tile, because they're very easy for the installer from an install standpoint. And yet you also get the performance later on down once they cure out. Its TG goes up, and so it resists movement, indentation, etc. over time. These are by far the more popular types of adhesives that we're seeing on the market. They can be used for carpet tile because they do start off very, very sticky and soft. However, keep in mind that a true pressure sensitive releasable, you can actually lift up the material over time later on. With a transitional, you cannot, because those become very rigid, become very hard, and so they become a permanent type of installation. So you have pressure sensitive releasable, and with a transitional, you have pressure sensitive permanent. So keep that in mind when you're picking your adhesive as well. So the performance attributes, as I said, you can change the polymers. In order to get a wide range of performance attributes depending on what you're looking for. Usually they're designed for rubber flooring, and most particularly they're designed for what we're seeing in the industry now, which is vinyl flooring, vinyl back carpet, and LVT and LVP. The downside, they can be a little bit more expensive than an SBR. However, we're talking dimes instead of dollars per square foot in comparison to some of the other adhesives that are there. They also dry by coalescence, so water has to evaporate. pH is very important. Again, contaminants, moisture, and temperature also very, very important. We always talk about acclimating the material. You also have to acclimate the area that you're working in when you're dealing with any type of adhesive, but particularly with your acrylic latexes. Recommendations, they can be used for carpet, but they're not usually used for carpet. We say functional, but very, very minimal leg development. So its initial tack isn't that great. So when you're using them for carpet, you have to build them up a lot in order to get enough tack. That gets very expensive. You're way better off to go with an SBR. However, for all of the other types listed there, they are the adhesive of choice. Reactive adhesives, completely different. You get to be a little bit of a chemist when you get on site, when you're using reactive adhesives. Stoichiometry, all that means is part A and B have to be combined perfectly and in exact amounts in order to get the results that you're looking for in the adhesive. Why is that important? Because when you get on site, you do not have a choice of backing off A's and B's in order to make your own type of adhesive, maybe some of the qualities that you want. In order for these reactive adhesives to work, you have to be mixing the A and the B. So you will see when you open up a bucket of reactive adhesive, be it epoxy or hybrid urethane, you're going to see that you have a B part in there. You need to use all of the B, and you need to mix it with all of the A in order for these to work properly.
So also known as two-part epoxy, that sort of thing?
Two-part epoxy, two-part urethanes.
Yep.
So typically in the flooring industry, I put reactive up here instead of epoxy, because the urethanes also, they're usually a hybrid. And so they do have typically an epoxy hardener. The urethanes are hybrid into that in order to build them the way. So they're kind of very, very close to being an epoxy with some different characteristics. What you're going to find with reactive adhesives, these are the highest bond strengths. Epoxy is going to be a little bit higher than the hybrid urethanes. They bond to many types of materials rather. They're very moisture resistant. They're designed for very, very heavy commercial use. Industrial use, you're going to be going to reactive adhesives. Waterproof areas, you're going to want to go to reactive type adhesives. There is a downside, particularly to the epoxies. They can cause allergic reaction. They're exothermic, so these can be very, very difficult to work with, particularly if you leave them in the bucket. You can see in that picture that's actually a melted bucket from using an epoxy, not taking it out, because the bigger the mass, the faster they cure, the hotter that they're going to get. They have no green strength. So in other words, when you first put them in, they don't have a lot of strength. And so a lot of times you're going to have to weight down the material and let them build their strength. So they can be a little bit more challenging to work with from an install standpoint. However, from a performance standpoint, you cannot beat a reactive adhesive. It will be the strongest. We use these in arenas. So you're going to use them in hot and cold. You're going to be using them behind the boards in a hockey arena with rubber flooring, etc. That's where reactive adhesives are mostly used. They are very expensive to use as well. And so typically they're only used in very certain areas of projects. They cure by chemical reactions. So again, the A and the B needs to be mixed together. The chemists that have made these up, they have already pre-measured for us in order to mix them, and they know how they work. And so their mix is probably the best to use. So please do not be monkeying around with the mix between those two. Where they're used, they're not used for carpet because they have zero leg development, they have zero wet suction, and so their immediate grab is not there. So rarely do we use them for carpet or vinyl back carpets even. VCT, resilient flooring, solid vinyl flooring, rubber flooring is usually where these are used, and usually in high traffic, industrial, heavy commercial type areas.
That's a good point to make. Vulcanized rubber, most rubber tiles, unless they're re-vulcanized, will naturally curl up, right?
That's right.
So you need bricks to hold them down to that two-part epoxy.
Yeah. If you go on a job site where they're using these two parts, you'll often find that, and in fact, the manufacturers in their installation instructions will actually have ways, the means laid out in their installation instructions as to how to weight them down, what types of weight to use, where to put the weights, et cetera, when you're dealing with these types of adhesives. Urethane or polyurethane adhesives, that term is interchangeable. These are single component urethanes. So we just talked about reactive adhesives, which are two component. There's an A and the B to those. These only have one. There's only an A. So when you open the bucket, there's nothing else in there other than the adhesive. 100% solids, no solvents in these. Really good bond, good tensile strengths, resilience. Typically, a urethane adhesive is going to be used in the wood industry. So you're going to see urethanes or polyurethanes are used in wood. Why is that? Because they have a lot of movement. So you can manufacture these in order to stay very, very flexible. So as wood expands and contracts with humidity, they can expand and contract with it without them shearing off. If you use a reactive adhesive with these, reactive adhesives tend to be a lot brittler. And so if you use those with wood, the wood will actually shear off the adhesive. So in the wood industry, we typically go to polyurethane adhesives. There are some single component polyurethanes in the sport flooring industry used with reground rubber, etc., but it's very, very select. Typically, you're going to see a polyurethane used in the wood industry. I just missed that last slide, but I don't have time to back up. So moisture cured polyurethanes, what these need and what this means is they need moisture. So without moisture, these will not cure. And so we have to make sure that either there's moisture in the environment, and sometimes even we have to make sure that there's moisture in the substrate in order for moisture cured polyurethanes to kick off. You may hear sometimes we tell you to spritz the adhesive before you put the wood into it. That's because it needs the moisture in order to kick and in order to cure. That's why we're asking you to do that with moisture cured urethane.
So if you're installing a floor in Death Valley, don't use moisture cured polyurethane adhesive.
That is exactly. And sometimes in Alberta too. So moisture cured polyurethanes, those also are at the beginning of their downward slide because of technology, etc., and some really, really good chemists in the adhesive industry. Silane-based adhesives are slowly starting to replace polyurethane-based adhesives. The only thing that's really holding back silane-based adhesives is cost. They tend to be a little bit higher than polyurethane. And so polyurethanes are still kind of holding their own, particularly in the wood industry. But you are going to see over the next number of years, silane-based adhesives are going to become the more popular. They're very, very similar chemical structure, but there's no isocyanates and in a silane-based adhesive. And so the chemical makeup is a little bit different. they tend to be a little bit greener of a and more sustainable type of product. They're way easier to work with than a polyurethane. So if you're an installer, you will love silane-based adhesives because you can clean them up with water. Excuse me. They have the same strengths, etc. They have all of the same qualities that a polyurethane has, only they're just a little bit easier to work with. What's happening also in the industry is the silane-based are easier to modify. So they're being modified for resilient flooring, LVT flooring, and rubber flooring in order to, and they will slowly take over and start replacing the two components as well, because we're getting very, very good performance characteristics from these adhesives, and we're not having to use the two component. So you're going to see silane-based get more and more popular over the next little while. They are dependent on moisture, so again, we have to make sure that we have moisture on site. So particularly with resilient flooring, you're going to want to be able to introduce moisture either into the adhesive somehow. So you might have to spritz the concrete before putting it in, or you may have to spritz the silane modified as we go. Not sure where the little things are coming from there. Again, they cure on exposure to moisture or humidity. Too much or too little moisture, again, can affect. So Death Valley, you got to be very, very careful if you're working with these, and temperatures as well will affect your silane base. So engineered wood, definitely, and now solid vinyl floorings and resilient floorings are starting to be used with silane modified. So
that's great. It's a win-win product coming to industry over the next, what do you think, year or two? Is
I would say probably over the next 5. Silanes are really going to take off, just as once technology gets up there, costs tend to come down. Once you get more and more of these in the industry, costs tend to come down, so they'll start to slowly displace the polyurethane type adhesives over time.
Easier for the installer and delivers an equal product. Awesome.
Yeah, absolutely. And that's actually a good point, because the installers are going to start asking for them. You're going to start seeing more and more of them as well. So critical success factors. So SBRs, don't use with plasticized flooring. Acrylic based, open and working time recommendations. PSA type adhesives, so pressure sensitive, don't leave them open too long. Why? Because if they're a transitional, you will miss the point where you're going to get bonds, so they're going to stop being sticky at a certain point. If it's a releasable pressure sensitive, just the environment. They're great dust collectors, so just dust in the air, they'll collect that. Epoxy, make sure you mix them A and B together properly. Urethanes, proper temperatures, humidity, etc. And silane based, again, humidity and proper temperatures with the silane base. Easier to clean up though. Some comments on what we're seeing in the industry is high moisture acrylic adhesives. Just a few comments on these. I'm not going to get into how moisture works, etc. You realize that it comes out of, if we're dealing with a concrete situation, you're going to have moisture in the concrete, either introduced in the concrete itself, so it's in the mix, or coming up from underneath. High moisture acrylics, you're seeing more and more of them into the market. The way these work, you will find in the manufacturer's directions with high moisture acrylic adhesives that usually they're going to recommend, if it's an acrylic type one, it's going to be a pressure sensitive transitional, and they're going to recommend you go in at the pressure sensitive stage. The reason for that is because you want all of the moisture in the acrylic adhesive to be gone. You want only the good stuff left in there, so you only want the polymers left in there. Otherwise, they can re-emulsify with the high moisture that comes out of the slab. That's dealing with acrylics. The silane modifieds now are also very high moisture. Epoxy is very high moisture adhesive as well, but just for the acrylics, you're seeing higher and higher moisture levels allowed in concrete slabs. The other thing to remember is they're really only meant to buy time for fast track construction. So they're only really meant for what we call dissipating moisture, moisture that we know is going to be leaving the slab. It just gives you can get on the slab faster. If it's an actual problem, so if you have hydrostatic pressure or water coming up through the concrete, that is not what high moisture acrylic adhesives are meant to handle. They're really only meant to handle moisture vapor that is existing in the concrete itself, and they are not waterproof. So they are very highly water resistant. However, they're not waterproof. So if you need a waterproof adhesive, you're going to be going to a reactive urethane, or even a silane modified is going to give you waterproofing. Critical success factors. My son is a really big racing fan, so I've been compelled to follow him in his passion. It's meant a lot of early Sunday morning because he loves F1. What never fails to amaze me with F1 is the importance of the tires. So you have $100 million plus sport, maybe even 200 million for the winning teams. They put all of the development into the engines, into the car. They develop the drivers, the team. All of that is very, very costly. And yet the success on whether they win or lose very often comes down to the end of the race and the tires, where the rubber hits the road. So many races are won and lost on that. Interestingly, trowels are the tires of the installation industry. They play a very, very small part in the makeup of the entire team or the entire construction process. And yet they make up a large part of the failures of whether or not you have success or not. You can have $100 million project, use the wrong trowel, or you let the trowel wear out, and you're not going to have a successful project. Very, very similar to racing tires.
So Brent, how many trowels, I mean, as you know, it's a V-notch trowel, and it starts with a 1/8 gap at the top, the 2 points between the V's, and you wear it out, then it becomes 1/16 between the V's. How many square feet does that take to happen?
So on concrete, we actually figured it out, 1,500 to 2,000 square feet on concrete. If you're dealing with gypcrete, when I was on tools, we had gypcrete where we were changing trowels in between spreading on a vinyl floor. So they would wear out extremely quickly. So you have to be very, very careful of the lifespan of the trowel. They are a metering device. They do various things for the adhesive, various things for the success of the installation. When I was on tools, I used to think that trowels were just a sales tool for the adhesive manufacturers, but I did learn once I started with MAPEI, trowel size is not decided by the sales department. Trowel size is decided by the chemists that build the adhesives. So the trowel size that's put on the bucket is the trowel size that the chemist has figured out. This will get you the maximum performance from the adhesive with the minimal amount of adhesive being used. So how do we read a trowel? So you're going to see on any of the trowel manufacturers, you'll see them on the trowel themselves. You'll see the A, B, and the C. A is the depth of the notch, B is the width of the notch, and C is the space between the notch. Different size trowels can represent a significant reduction or increase in how much or too little adhesive gets put down. If you put down too much adhesive, you're going to get blobs underneath, and particularly on a vinyl floor, that can be very, very ugly. You can get telegraphing of footprints, etc. Just to give you an idea, One of the most popular trowels that we see here on the prairies is the number 25. Every guy loves the number 25. It gives you lots of coverage, and a lot of guys feel that they're getting enough coverage. I like to recommend the number 30. The difference in coverage between a 25 and a 30 is about 30% in coverage. The difference in square foot cost is a little bit less than 10 cents a square foot that you're dealing with in the cost of the installation. So for 30% less coverage, you're saving less than 10 cents a square foot. I'm not sure if you went to an owner and told them you could save them 10 cents a square foot if we just reduce the performance of the adhesive and thus the performance of the floor covering by 30%. I'm not sure that any owner, architect, etc., is ever going to take that deal. So be very, very cognizant of trowel sizes. Again, our chemists put them on the buckets. They will be on all of the data sheets for any of the adhesive manufacturers. The reason for that is because this is a very, very important part of the installation process. Once you've got all of that down, you've figured out exactly which adhesive you want to use, you've figured out which trowel you're going to use. The NFCA reference manual has a really, really good section, A11, on bond testing. So bond testing are conducted to see if the flooring adhesive will bond to the flooring product. Usually we already know that. If you talk to the manufacturers, they can tell you which adhesive to use. Then we have to determine whether or not it's going to bond properly to the substrate that we're going over. So this is outlined in the NFCA manual, how to do it. It's a 24-inch square, 600 millimeters if you're in metric. You use the adhesive, you use the patch that you're going to use, you go over the substrate that you're going to go over. So this is done on site. You're not doing this in your shop. You're going on site, you're gluing this down 72 hours, let it all cure out, make sure that you have proper curing of all of the products that are there. You come back after 72 hours and you cut 2-inch sections in strips and start pulling them up. Try and pull up straight as possible. If in the NFCA manual, we state an unusual amount of force is required, it can be concluded that the material is securely bonded. These are qualitative tests. They're not quantitative measurements. There's no actual number that is going to be required. However, if you need a number, you can actually use a fish scale. So you can actually hook a fish scale up. Don't use the one that you cheat with in order to make people think you caught a bigger fish than you did, but use a real one. And then you can use the fish scale, and that'll give you an actual kilogram of the force that's necessary. You can figure out then how much force is required. Why that might be important is because you may have different guys doing the bond test. So you might have a skinny, weak guy doing it one time, and you might have a really strong guy doing it the next time. If you want to be able to benchmark exactly what the numbers are, then you can actually use the fish scale. If not, it's what we call an unusual amount of force is required. It's really common sense. Once you start pulling up, you're going to know whether or not you have bond. So failure modes, can you guess which one is the best one or the only one that passes? So you can have a pass with a failure. I made it easy. I put it in green for us. So an adhesion failure means that the adhesive did not bond to the substrate. So the adhesive actually came right off the substrate. So obviously there's something on the substrate or something that's preventing the adhesive from absorbing into the substrate. So that needs to be addressed. A product failure, actually the product itself has been pulled apart. Typically that can be a pass as well because you have a really good bond and the products are not typically made in order to fail. A substrate failure means that you've actually pulled the substrate apart. In a substrate failure, You may need to do some remedial work to the substrate itself in order to get it to a point where you can actually bond properly to it. So by all means, reference the manual, because all this is there in order to do a proper resilient bond test in order to ensure success on your projects. So, so you may think that we went a little bit of speed golf instead of regular golf. We went through an awful lot of chemistry, some practical suggestions, industry standards. We did go through it quickly, but the NFCA is definitely your resource. We can give you education in depth. We do it every month. If you need further questions, absolutely, you can reach out to the NFCA as well.